Good morning, students. In the previous class, we discussed about the stereoisomerism and the fission of the covalent bond. The fission of the covalent bond takes place in the two ways, that is homolysis and the heterolysis. This we are discussed in the previous class. In this class, we are going to be discussing about the nucleophiles and electrophiles. Here, the first we are going to be discussing about the nucleophiles. Means the nucleophiles means that is a nucleo. Nucleo means nucleus. Nucleus. Then phile means that is affinity. Affinity. This is the meaning of that is nucleophile. That is nucleus affinity. Means here the nucleophiles are defined as electron rich species. The electron rich species is called as nucleophiles. It is called as nucleophiles. Otherwise it can be defined as that is a reagent which can donate a pair of electrons in a reaction. ಯಾವುದೇ ಒಂದು reagent pair of electrons donate ಮಾಡಕ್ಕೆ ರೆಡಿ ಇದ್ರೆ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಅಂತದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, that is called as a nucleophiles. Yeah, the nucleophiles we can be defined in the two ways. One is electron rich species are called as the nucleophiles. Electron rich species called as the nucleophiles, and the reagent this also be we can also be defined as the reagent which can donate a pair of electrons in a reaction is called as nucleophiles. In this there is example for this nucleophiles we are going to be taken, that is OH minus, then Cn minus, NH2 minus, or COO minus, etc. These are all examples for the nucleophiles. Nucleophiles ge examples ivella. Nucleophiles ge example ivella reagents. Idu yavade species tagondru kuda electron rich irutte. Electron rich iruttadನ್ನ ನಾವು ಎಂತ ಕರೀತೀವಿ, nucleophiles. That is going to be mentioned with the minus sign. Minus sign mention ಆಗಿದೆ ಅಂದ್ರೆ ಗ್ರೂಪ್ ಆಫ್ ಆಟಮ್ಸ್ ಮೇಲೆ ಅಥವಾ ಒಂದು ಆಟಮ್ ಮೇಲೆ ಒಂದು ಮೈನಸ್ ಸೈನ್ ಇಂಡಿಕೇಟ್ ಆಗಿದೆ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ ಈಸ್ ಎ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. ಎಲೆಕ್ಟ್ರಾನ್ ರಿಚ್ ಇದೆ ಅಲ್ಲಿ ಅಂತ, ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಇದೆ ಅಲ್ಲಿ ಅಂತ ಅರ್ಥ. ದೆನ್ ನೆಕ್ಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಡಿಸ್ಕಸಿಂಗ್ ಅಬೌಟ್ ದಿ ಎಲೆಕ್ಟ್ರೋಫೈಲ್ಸ್. ದೆನ್ electrophiles means electron loving. Electrophiles, the meaning of this is electron loving. That is electron loving reagent means it is going to be electron loving because these are electron deficient. ಅಲ್ಲಿ electron deficient ಇರುತ್ತೆ, ಅದಕ್ಕೋಸ್ಕರ ಏನಾಗುತ್ತೆ, this can attach the nucleophiles easily. Means ಇದಕ್ಕೆ ಇದು electron deficient that is nucleophiles are electron rich species. Therefore these two can easily react with each other. Means ಇದು ಡೊನೇಟ್ ಮಾಡಕ್ಕೆ ರೆಡಿ ಇರುತ್ತೆ, ಇದು ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಕ್ಕೆ ರೆಡಿ ಇರುತ್ತೆ. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಫೈಲ್ ಇನ್ನೊಂದು ತರ ಕೂಡ ನಾವು ಡಿಫೈನ್ ಮಾಡಬಹುದು. ಯಾವ್ದಂದ್ರೆ the reagent which can accept a pair of electrons in a reaction are called as electrophiles. Otherwise it is electron deficient species is called as a electrophiles. Electron deficient species na electrophiles anta karitivi. Otherwise it is going to be defined as a reagent which can accept a pair of electrons in a reaction is called as electrophiles. Example for this electrophiles is H plus, Br plus, Cl plus, NO2 plus etc. These are all examples for the electrophiles. Electrophiles ge idella example agutte. Suppose the reaction between the nucleophile and the electrophile. Suppose the nucleophile is the one OH minus. We are going to take an answer. Question: the reaction between these two, that is the reaction between the nucleophile and the electrophile in this the movement of electrons is going to be represented by the curved arrow in the represent ಮಾಡ್ತೀವಿ. That is where the electrons is going to be shifting, which electrons is going to be shifting, there is going to be arrow is going to be starts, and the location where it is going to be attacked, that is going to be ends with the arrow. Means here we are going to be get this water molecule. That is water molecule. This about the nucleophiles and the electrophiles. ನಿಮಗೆ electrophiles nucleophiles ಏನಂತ ನೆನಪಿಟ್ಕೋಬೇಕಂದ್ರೆ nucleophiles is electron rich, electrophiles is electron deficient. Nucleophiles which can donate a pair of electrons, the electrophiles which can accept a pair of electrons. This example for this nucleophiles, this is the example for the electrophiles. The next we are going to be discussing about the electron movement in the organic reactions. We will discuss the electron movement in the organic reactions. Electron movement in organic reaction. The next we are going to be discussing about the electron movement in organic reaction. That is electron movement in organic reaction. And that's what happened. The electron movement in organic reaction is, that is, it's going to be represented by, andre electrons movement ಆಗೋದು reactions ಅಲ್ಲಿ ಯಾವ ತರ represent ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ by using the arrow curve. Means from where it's going to, which electrons is going to be shifting to which location. Means it shows the shifting of the electrons from either bond to bond or bond to atom or atom to bond. That we will see some examples. First we will discuss about the shifting of electrons from one bond to the adjacent bond. That is if you are going to be taken this, here it's going to be represents, this arrow mark is going to be represents the shifting of electrons, that is a pi electron pair, shifting of the pi electron pair from the one bond to the adjacent bond. ಅಂದ್ರೆ ಒಂದು ಬಾಂಡ್ ಇಂದ ಪಕ್ಕದಲ್ಲಿರುವ ಬಾಂಡ್ ಗೆ ಶಿಫ್ಟ್ ಆಗ್ತಾ ಇದೆ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್, ಅದನ್ನ ನಾವು ಈ ತರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. Then after shifting we are going to be get like this, that is A single bond, B double bond, C. Then the next case we are going to be discussing about the second case, the movement of the electrons. Shifting of the pi pair of electrons bond to the adjacent atom. Bond in the adjacent atom ge yav tara shift agutte anta nodona. That is going to be, it's going to be represent, it is going to, this pi pair of electrons is going to be shifting to the adjacent atom, that it's going to be shows that is the, we are going to be get that is after shifting the electron pair to the adjacent atom, it's going to be represent like this electron pair and single bond C. This is about the after the shifting of the pi electron pair to adjacent atom. Next, third case, shifting of the electron, lone pair of electrons of an atom to the bond. We are going to be shows that this case is little different. Means lone pair of electrons iruttalla, adu ಪಕ್ಕದಲ್ಲಿರುವಂತ ಬಾಂಡ್ ಗೆ ಶಿಫ್ಟ್ ಆಗ್ತದೆ. It's going to be shifting the bond, adjacent bond. It is going to be represented by, that is A single bond, B double bond, C. This about the movement of the electrons, either here bond to the bond and here bond to the atom. Here that is the lone pair of electrons atom to the bond. This is about the electron movement in organic reaction. The next we are going to be discussing about the electron displacement in the organic reactions. Electron displacement in the organic reaction is going to be explained in the 4. Electron displacement in organic compounds. Next we are going to be discussing about that is the electron displacement in organic compounds. That is electron displacement in organic compounds. This can be explained in the 4 different ways. That is the first one is inductive effect. The second one is resonance effect. Third one is electromeric effect. And the fourth one is hyperconjugation. That is hyperconjugation. Yeah, the one thing it's going to be explained, one is inductive effect, second one is resonance effect, and electromeric effect, and hyperconjugation. In this class, now we are going to be discussing about the inductive effect. What is meant by inductive effect? The inductive effect means the permanent displacement of shared pair of electrons to the more electronegative atom from the carbon chain. That is, inductive effect means the permanent displacement of shared pair of electrons in a carbon chain to the more electronegative atom that we called as an inductive effect. It's going to be represented by the I. This effect is going to be represented by the I. Here we take one example. That is, carbon atom is attached with the chlorine. The carbon atom is attached with the chlorine. We take the example. That is CH3Cl. There is when chlorine is more electronegative. The chlorine is more electronegative than the carbon. The chlorine is more electronegative than the carbon. Therefore, the shared pair of electrons between the carbon and the chlorine is going to be shifts towards the chlorine. At that time, this carbon gets the partial positive charge and the chlorine gets the partial negative charge. Andre ಇಲ್ಲಿ electron shift ಆಗಿದ ತಕ್ಷಣ ಇಲ್ಲಿ ಏನಾಯಿತು, electron rich ಆಯಿತು, ಅದಕ್ಕೋಸ್ಕರನೇ partial negative charge ಹಾಕ್ತೀವಿ. ಇದು electrons ಬಿಟ್ಕೊಡುತ್ತೆ ಶೇರ್ ಆಗಿರೋ electrons ನ, ಅದಕ್ಕೋಸ್ಕರನೇ ಇದು electron deficient ಆಯಿತು. Therefore this will get the positive charge, partial positive charge. This about the inductive effect. Here the inductive effect is going to be weakened when the distance is increases, distance increase ಆಗ್ತಾ ಹೋದಂಗೆ inductive effect is going to be decreases. Inductive effect is going to be decreases. That is going to be explained by using the, that is propyl chloride, that is CH3 CH2 CH2 Cl. What happens? That is it's going to be one aroma, it's going to be two aromas, it's going to be three aromas. Three aromas in the represent. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ partial positive negative charge ಇರುತ್ತೆ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ partial positive charge, partial positive charge. This is about the partial positive. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಡಿಸ್ಟೆನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆದಂಗೆ ಏನಾಗ್ತಾ ಇದೆ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ತೀರಾ ಕಮ್ಮಿ ಆಗ್ತದೆ. ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ is going to be decreases. Inductive effect is going to be decreases. This about the inductive effect. The inductive effect is of two types. That is negative inductive effect. That is going to be represented by minus sign, inductive effect. Then positive inductive effect. Positive inductive effect. Here the negative inductive effect means, here negative inductive effect means if the group attached to the carbon chain more electronegative than the hydrogen, at that time the shared pair of electrons is going to be shift towards the substitute and towards the negative electronegative atom. Means if you are going to be taken the example for this is, that is CH3Cl. Here this chlorine atom is more electronegative than the hydrogen. At that time the shared pair of electrons is going to be shift towards the fluorine, At that time this carbon gets the portion positive charge, fluorine gets the portion negative charge. This type of effect we called as a negative inductive effect. Is called as a negative inductive effect. We will take the positive inductive effect. The negative inductive effect ಯಾವಾಗ ಬರುತ್ತೆ ಅಂದ್ರೆ if the groups like CN, COH, then some other example, that is chlorine, bromine, ಇವೆಲ್ಲ ಬಂದಾಗ ಏನಾಗುತ್ತೆ ನೆಗೆಟಿವ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ತೋರಿಸುತ್ತೆ. ಅದೇ ಪಾಸಿಟಿವ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ ಅಂದ್ರೆ that is that the group is attached to the carbon chain is less electronegative than the hydrogen atoms. At that time the shared pair of electrons shift towards the carbon chain, that we call as a, that effect we call as a positive inductive effect. This we can be explained by the using the, that is CH3Z. This Z is general representation. This is less, Z is going to be represent the less electronegative than the hydrogen. At that time the shared pair of electrons shift towards the, that is carbon chain. Therefore the carbon gets the portion negative charge and this substituent will get the portion positive charge. This we call as a positive inductive effect. This example for this the group which shows the positive inductive effect is, that is CH3 twice this group, then CH3 twice this group, and that is CH3 CH2 this group. The all the groups is example for to show the positive inductive effect. Adhe idike negative inductive effect ge, that is it's going to be COH, CN the cyanide group, COH group, ಇವೆಲ್ಲ ಕೂಡ negative inductive effect ತೋರಿಸುತ್ತೆ, ಇವೆಲ್ಲ positive inductive effect ತೋರಿಸುತ್ತೆ. This is about the inductive effect. The next class will discuss about the resonance effect or mesomeric effect. Thank you.